Graphing quadratic equations from standard form. This will be a review because we've done part of this before, except we're going to use something new as part of it this time. The first example is to graph the function x squared plus 10x minus 7. First thing you have to do is find the y-intercept. Do you remember how to find the y-intercept? You can find it from the form y equals mx plus b if we were doing a linear equation. And in that case it would be this down here, but we're not doing a linear equation, we're doing ax squared plus bx plus c. So where is the y-intercept in a quadratic equation? It's at c. So c is going to be the y-intercept. And in this case it is -7. To find the x-intercepts of a quadratic equation, what should we do? One way to find them is you could factor. So what two numbers could I come up with that multiply to get a -7 and then add to get a +10? What two numbers could I use to get -7? What two numbers multiply to get -7? 1 and -7. So 1 times -7 would give me -7, but do those add to give me +10? No. Could I use -1 and 7? Do those add to give me +10? Are there any other numbers that multiply to get -7 and then add to get 10? There are not. So if you can't factor it, then you have to use another way. What other way could we use to find the x-intercepts? Yeah, we could use the quadratic formula. So there's the first step. We've plugged in 1 for a, which shows up here and here. And then b is 10. It goes here. Remember, there's already a negative sign in the formula. And it also goes here. And then we have c is -7. It goes in back here. So we would have to start simplifying that. We would have to do 10 squared, and then minus, we have 4, 1, and -7. Minus sign, and then times -7. That makes it a plus. So we would have 10 squared minus 28. And on the bottom, we could simplify this to 2. So -10 plus or minus the square root of 100 plus 28, and then all of that over 2. Clearly, you can simplify 100 plus 28 to come up with the square root of 128. Now, if this were just a normal problem in which we were solving, just for the sake of using the quadratic formula, then we could leave it like that. But we're graphing this, and we have to find the x-intercepts. So we have to work it all the way out. You have to do -10 plus the square root of 128 and come up with an answer and divide it by 2. We're going to round this to 2 decimal places so that we can find an accurate spot on the graph to put it. So if you multiply that out and do the division, actually add it and then do the division and then subtract and do the division, you should come up with 0.66 or -10.66. We have to find the vertex of this problem. And we're going to find the vertex using what we did this week, where when you complete the square and you can put it in a vertex form and then pull out that point of the vertex from that form. So we would have to start with this. We would have to group these two items together here and leave a space. There's no number other than positive 1 on the x squared, so there's nothing to take out of that. What's the first thing we do in order to find the item to fill in this space? Half of 10, and then what do we do with it? Square it. Okay, so half of 10 is 5, and we square that to get 25. So we've added 25 inside the parentheses. However, since we're staying on the same side of the equal sign, we've added 25 on this side, so we've altered the value of the equation. To get it back to what it was before, we have to do the opposite of what we just did here, which is subtract 25 on the outside. And then simplify on that outside. Negative or minus 7 minus 25 should give you minus 32. And then we need half of our 10 here to get this 5. We're using this sign and this variable. Square the quantity. So what should the vertex be of this graph? Negative 5 and negative 32. So there's our vertex. Okay, we have to determine the range of the x-axis and the y-axis on your graph paper. The graph paper has no x-axis or y-axis. You have to put them on there, like we did before. So with all of the information that we've gained up to this point, the y-intercept, the x-intercepts, and the vertex, we have to figure out the best place to put the x-axis and the y-axis. So you have a y-intercept of negative 7. So that means on the y-axis you must be able to go down to at least negative 7. This is a y value. Are there any other y values on this screen? What is another y value? Negative 32. Yep, that's a y value too. So now we have to go even further down on our y-axis. We have to be able to accommodate at least a negative 32. You won't have 32 spaces on your graph paper, so you'll have to alter the range so that one block doesn't necessarily equal 1 unit. It could be 2, 3, 4, whatever you need to make it. So our y-axis has to go down to at least negative 32. What about our x-axis? Yeah, we're going to have to go to the left at least negative 10.66, and then to the right at least 0.66. That's all we need to account for on the x-axis. Now we have a negative 5 here, that's an x value, but it's in between these two, so it's already accounted for. So with that information, we have to go to our graph paper and figure out where to put these axes so that we don't waste a bunch of paper and we can zoom our graph in and get a better view of it. So here's my graph paper, and I know I've got to go from negative 10.66 over to 0.66. So I've left some space over here on the right side of the y-axis. And I have all this over here to make it to about a negative 11. For the y-axis, I know I had to go down to at least negative 7, but then I had to account for that negative 32 as well. There really isn't much above the x-axis that we have to account for. There's nothing up there that we have to plot. So you should put your axes in this position. Okay, so the first thing you should do is mark the values on the x-axis and the y-axis. In other words, you have to come up with your range. Can each block in both directions equal 1 unit? Or should it be 2 units or 3 units? If you want to go with 2, that's fine. If you want to do 3, that's fine. Whatever works best for you. Here's what I did. Going from left to right over here, I've gone every 2 blocks is 1 unit. So I have a -1, -2, -3, -4, and I didn't have to write the numbers underneath each one. Here's -10, which leaves me still 2 more blocks to get to -11, so I can plot my point back there. And then going down the y-axis, every block is 2. So -2, -4, -6, -8, -7, or not -7, but -10, -12, and so on, all the way down to -32. And notice that I still had some space left over that we really can't account for, because if I had gone any wider than that or taller, then it wouldn't be enough room to fit it all in. So the first thing you should do is plot the y-intercept. And there's my dot. The y-intercept is 0, -7. So find -7 on the y-axis, make a dot, and then name the point 0, -7. That means you go left or right, 0, down 7. You have to plot the x-intercepts next. So I have one at 0.66, so that means I've gone 0.66 to the right and up 0. So that is the point, label that accordingly. And then the other x-intercept is -10.66 back here, so that is -10.660. I went back this amount and up or down 0. So you got to put the vertex on next, and the vertex was -532. So go back 5 and down 32, and then label the point off to the side of it. Keep in mind when you label, you don't want to put it right in the path of the graph that you're going to have to draw. Draw the axis of symmetry on your graph, and it's a vertical line that goes through the vertex. That'll let you know that your graph has been cut into 2 equal halves. So when you're drawing it, you need to keep in mind that the left-hand side should match the right-hand side. So the last thing you have to do is actually trace in the graph. This is what it should look like. Notice you have a curve here. It is not a V shape that comes in like this. If you do a V shape with a point, it's not going to count. In reality, that would be an absolute value type of a graph. We're doing a quadratic equation. So it's got to have a continuous curve to it like this, and it's expanding outward ever so slightly as it goes up on either side. This is the work. The y-intercept is -8, x-intercepts are -2 and 4, and the vertex is 1 and -9. And here's my graph. I stretched it out as far as I could, left and right, and top and bottom. If you come up with something like this, way up in here, and you have all this space that's unused, then you got to go back and redo it.